8 plus 5 means you are shifting your waveform. This is the 0 line and this is your V in suppose. So after adding VCC by 2, this 0 entire line will switch to the VCC by 2. So let me draw. Over here, this is your VCC by 2. Let's take this is 0 line. Now you shifted your input, right? Like this your input waveform will become now. Okay, wait a minute. Now, in the 555 timer, we had 3 series 5K, 5K, 5K. Is it okay? The threshold was connected at positive terminal and from here we were getting some input into the negative like this, and from here we were getting in positive feeding. Okay, so this was trigger. This was trigger, sorry, the trigger was connected over here in the lower terminal. Trigger. So what is going on over here? Here VCC. What is the voltage over here? It is 2 by 3 of VCC. Is it okay? What is the voltage here? It is 1 by 3 of VCC. The series division rule simply you can apply over here, the voltage division. So you will get 2 by 3 of VCC, 1 by 3 of VCC. Now here you connected threshold there, VT. Now if you will talk about V threshold, should be greater than to this point. This point is nothing but 2 by 3 VCC. When VTH is greater than 2 by 3 of VCC, you will get at this output 1. Is it okay? And in this case, if your 1 by 3 of VCC is greater than trigger, then also we are getting 1 over here. Is it okay? But this is undesirable condition. So in this condition, suppose your trigger, V trigger is greater than 1 by 3 of VCC, you will get 0 over here. Okay, and this will fit to the SR. So what I mean is, you have to remember this 2 by 3 VCC and 1 by 3 VCC, how I got this. Okay, so the condition is like, I can draw over here, this is the 2 by 3 of VCC and 1 by 3 of VCC will come over here. Okay, so okay, now let's see. This is your input you are applying over here, see, or at the trigger point or threshold point. Okay, so what is the point? When this become greater than threshold, the condition is the threshold should be greater than 2 by 3 of VCC, then only at the output you will get 1. But by this waveform, at one time you will get greater than 2 by 3 of VCC. At this stage your output will become 0. Like this. I think it's confusing. Wait a minute. What I am saying is, after, if this condition is reverse, if 2 by 3 of VCC become greater than VTH, will get 0 or not? Tell me. 0, okay. So after this point, if this is the point over here, and before this point you are having 1, after this point suddenly you will be having 0. Okay. Is it okay, friends? Now what about 1 by 3? This 1 by 3. If this 1 by 3 condition according to the diagram is less than the trigger point, means beyond this it will switch to V plus. Like this you will get square wave. This is the output you will get. Okay. So the condition is the threshold was connected. So we were checking threshold should be greater than 2 by 3 of VCC, then only we'll get plus 1, else we'll get the 0, 1. Means if 2 by 3 of VCC is greater than, over here, this is the greater value. This is the 2 by 3 VCC is greater than this particular point. So here I'm getting sudden 0. Over here, like this. Okay friends. So this is the waveform of this schemic trigger. And here we are getting this schemic trigger plus Vset minus Vset plus Vset. It's a bistable multi-vibrator kind of thing. Okay, now we'll see a stable multi-vibrator with the help of 555 timer. A stable multi-vibrator. Okay friends. So 555 timer, let me take the 555 timer over here. 555 timer. In the 555 timer we have threshold and trigger. Threshold and trigger. They are connected over here, commonly connected. In this circuit I have RA and RB. And this RB is okay, perfectly fine. Over here this point is connected. Here I have capacitor C and this is grounded. From here I'm getting one wire and it is connected to discharge of it. Discharge. Okay, and it's grounded. So this is the unstable multivibrator. Let's see, is it unstable multivibrator? Means it's producing a unstable waveform. Square waveform, complete square waveform. So friends, over here, let me draw one table, then we'll observe this. This is VC I'm taking, here R, here is Q bar and output. Next step. Okay. Now I'm considering some values. Then I'll explain. Let me write it first. If VC is 0, R will be 0, S will be 0. Sorry, S will be 1, this 0, this 1. First condition finish. If this is greater than 1 by 3 of VCC, this will be 0, this will be 0, this will be 0, it will be 1 over here. Okay. If this is greater than 2 by 3 of VCC, I'll get 1, 0, 1, 0. Okay. If this is less than 1 by 3 of VCC, so 0, 1, 0, 1. So repeating now. Now see the situation. See what we are saying. If this VCC, here is the VC, voltage across capacitor is VC. Let's take it VC. Now what's going on over here? If VC is 0, if this is 0, means it threshold and trigger both are 0. So how you will compare the threshold point? Inside there is a 555 timer and something whose value is totally dependent on VCC. We are comparing the threshold voltage with 2 by 3 of VCC. When threshold point is greater than 2 by 3 of VCC, then only we are getting 1 over there. 555 timer circuit, yes. And this trigger point is connected to R, and this threshold point was connected to R, trigger point was connected to S. So, if 0 is the condition given, so 0 we are getting at the R. Okay, at the same time, we'll get 1 at the S. Why we are getting 1 at the S? Because for the S, trigger is which point? Yeah, trigger is 0. 1 by 3 of VCC, 1 by 3 of VCC should be greater than 1/3 of, triggering point, V triggering point. In this condition, we are getting 1 at the output. So let's check the condition. Is it satisfied? See, triggering is 0, we are taking 0 in this kind. Triggering is 0. So definitely 1 by 3 of VCC will be greater than 0. It will be 1 at the output. Yes. Now if the output condition is 0 initially, it will become 1. Is it okay? Now next condition. This VC become greater than 1 by 3 of VCC. This voltage become greater than of this. So definitely both will be 0. Both will be 0. Is it okay? Similarly, if this is greater than this, now the condition is this point is greater than 2 by 3 of VCC. So it's VTH kind of thing. VTH is greater than 2 by 3 of VCC. Definitely I'll get 1 over there. And this will be 0 and 1, 0. And in this case also you can check like this. So this is your table. Okay, what you are doing, just we are putting all these values of VC and we are checking what will be the output. So this is your output. So okay, now if you will take this entire thing in the waveform, so it will be looking like, let me draw the waveform over here. So here the capacitor is charging, then capacitor will discharge, charge, discharge, charge, discharge little bit, charge and discharge. This is the capacitor waveform you will get because of this circuit. Okay. So the max capacitor charging will go to 2 by 3 of VCC. Definitely we know this. And the minimum will be 1 by 3 of VCC. The capacitor will isolated in these 2 points. So definitely, because it's the output we are getting because of this 2-point comparison with the voltage, right? 2 by 3 of VCC and 1 by 3 of VCC. So this will be the capacitor. So in this condition, we have seen, let me draw the output waveform over here also. So in this condition, when capacitor was going to charge, your output was saturated. We are getting full high output. But once it is going to discharge, means before, because beyond 2 by 3, the threshold is greater than 2 by 3 of VCC, and suddenly you will get the 1 at the output. But if the condition become lower than this, it will be 0. So you are getting 0. Again over here, it will become like this. So you are getting this free running square wave. This is nothing but a stable multi-vibrator. A stable multi-vibrator. I hope it's clear to you, friends. Okay. Now let me take one example for you. The question given over here, we have to find out range of capacitor voltage. Range of capacitor voltage if the supply is given 9 volt for a stable multi-vibrator. This is a stable multi-vibrator given over here. Now let me draw the circuit. 555 timer given over here. Threshold, trigger and discharge. Okay, these 3 terminals, the threshold is connected with 3K like this, and this 3K is connected with 9 volt, and this same supply to the 555 timer also. After this 3K, we have 2K in the circuit, and the lower point of 2K is connected with trigger. Over here, it's capacitor like this. Between the capacitor and this, there is 3K, and this is discharge, right? This is the circuit given over here. Now, the options are given. They are asking the range 3 volt to 6 volt. Option B, 3 volt to 5 volt. Option C is given 3 to 4. Option D is given none. Okay friend, this is the circuit given over here. So these are the two fixed point over here, VTH, that is 6 volt, and V trigger, that is 3 volt. And student will do 3 volt, 6 volt is the answer. At the next moment, they lose their mark because this is not correct. In this case, the capacitor is connected over here. If this is true that threshold point and trigger point are 6 volt and 3 volt. Now you have to check this capacitor over here. What is the condition of this capacitor? See, let's take the trigger is 3 volt. The trigger is 3 volt. If trigger is 3 volt in this condition, what will be the charge on capacitor? Exact 3 volt, because this 3 volt is directly connected with the capacitor. So in this condition, the capacitor will charge up to 3 volt. So yes, capacitor will charge up to 3 volt, no problem at all. This will be the lower point. What is the upper point? So for the upper point, we have to consider threshold now. What is threshold point? 6 volt. Let's take this voltage is 6 volt. If this is 6 volt, what is the current over here? 1 milliampere. 9 minus 6, 3. 3 divided by 3 gets 1 milliampere. So this 1 milliampere current will drop over here 2 volt. 2k into 1, so 2 volt. So at this point, the voltage will be 6 minus 2, 4 volt. And this 4 volt is directly connected to the capacitor. So in this case, the maximum voltage can be 4 volt. So what is the range? 3 and 4. So where is 3 and 3 to 4? This is your correct answer. Is it okay? For any 555 timer, threshold point and trigger points are fixed. So based on this, you have to calculate the answer. You have to check the capacitor voltage, how capacitor is connected in the circuit. Now, let me take another one. So another circuit is given over here. I'm just considering the circuitry only, not considering 555 timer, but 555 timer is connected, okay? This is 3K, 2K, 1K, and here the capacitor is connected. Okay? This point is the trigger point where here, I'm sorry, over here is the trigger, wait, below 2. Below 2 is the trigger, here, this is the trigger point. And below 3 is the threshold point. This is threshold point, okay. Now this is the condition given over here. Again the question is same, the range of C. The range of C. Wait a minute. So here the given is, we're asking range of C, okay. Now the question is like this. VCC is 9 volt given over here. What is the threshold point? The threshold voltage is 2 by 3 of VCC. So 2 by 3 of VCC is again 6 volt. What is trigger? Trigger will be 3 volt. Now I have to check, first check for 3 volt. This is 3 volt given over here. Now this entire 3 volt is not coming to C. Then find out the current in this. This is 9, this is 3. 9 minus 3, that is 6, divided by resistance, that is 5K. So the current I'm getting is 1.2 milliampere. So 1.2 milliampere current is coming from the source. This current is coming over here and making drop of 1.2 volt. Okay friends. So the capacitor voltage is now this 3 minus 1.2. So that is 1.8 volt. So this is the minimum voltage. Now come to the next one, and that is, you have to keep 6 volt over here. Wait a minute. Now I'll consider the V threshold, okay? And I'll check the condition. So one point is the minimum. What is the maximum over here? This is the 6 volt. If this is 6 volt, the current is 1 milliampere. 9 minus 6, 3K. So 1 milli, and this is 6 volt. So drop over here will be 2 volt. Drop over here will be 1 volt. So 6 minus 3, This is the voltage over here. So 1.8 to 3 volt. Okay friends. So this is nothing but your range of capacitor charge or capacitor voltage. So friend, this is all about this unit. We have finished this unit now. From the next video onwards, we will take the questions only. Okay. So we have time. So let me take one problem today only. So the question is given. The circuit diagram R1. Over here it's R. I'm sorry. They are connected in op-amp, minus, plus. Here the given capacitor C, grounded, V0, R1, connected like this. Here this is V in, perfectly fine. Consider the op-amp circuit shown in figure. This is the op-amp circuit. The question is the transfer function V0S by VIS is. V0S divided by VIS they are asking. This is the transfer function. Means we have to convert this all in S domain. Then we have to find it. This is the gate 2007 2 marks problem. Okay, so capacitor will become like this, 1 by CS. The resistances will be like this only. This is V in and this is V0. We have to find the transfer function V0S by VIS. So what is the voltage over here? So voltage over here, this V in will be drop. This V in will drop over here. And V in will be, or the voltage over here is, suppose let's take VA. So your VA will be 1 by CS multiply with V in divide by R plus 1 by CS. Is it okay? So if you find out, it will come V in divide by RC S plus 1. This is your VA. The same voltage will appear over here also because it's a negative feedback given. Okay. So if you will apply nodal analysis over here, here the voltage, let's take V, that is equal to this V minus V in divide by R1 V minus V0 divide by R1 equal to 0. R1 will go away. So V minus V in plus V minus V0 equal to 0. Now you have 2V. 2V minus V in minus V0. Let's take V0 that side. Now you have to replace the V. So it's 2V in 1 plus SRC. Is it okay? Minus V in equal to V0. Now they are asking V0S by V in S. Okay friends. So it will be remain with, if you take V in out, V in will go that side. So you will remain with 1 by SRC minus 1. So let me clear some part, then I'll show you. So friends, I think we have done so many questions, right? So many gate questions we have attempted for all units. So I don't think so that we have need of any other class. So I think I'll end the entire subject, entire session today only. Let me come first with this answer. And the answer is 2 minus 1 plus SRC divided by 1 plus SRC. Is it okay? 2 minus 1 minus SRC divided by 1 plus SRC. So this will be 1 minus SRC divided by 1 plus SRC. Option is given or not? Yes. Option A is given for this. So for this entire question, your answer is 1 minus SRC divided by 1 plus SRC. So again, this is 1 minus SRC divided by 1 plus SRC. Okay friends. So see, this was the 2 marks problem. and hardly it will take 1 minute to get the answer. So you can see in the GATE examination they are asking this type of questions. What you have to maintain there, you have to maintain accuracy. Accuracy with time management is the key of success. Okay friends, so it brings me to the end of this entire session, this entire video lecture.